Hello, Baside. Hopefully I pronounced your name right, and hopefully this video finds you well. So I noticed you had a question where you ask if methane reacts with oxygen to produce CO2 and H2O. Uh, if 6 moles of CO2 are produced, how much O2 is used? Now, I would assume you said O2 because there was a typo, so I'm going to assume that that's what you meant. So first off, you have to understand what the chemical reaction is essentially a recipe to a chemical situation, right? When I say a recipe, this is just giving you the ingredients to the recipe, right? It's just saying I'm putting milk, sugar in. It doesn't tell you how much. So the first thing you got to do is you got to quantify how much you're using and how much you're making. And the way we do that is we go in and we balance the chemical equation. Now, the mistake that a lot of my students make is they think we're like going in like little tweezers and moving around molecules. And that's not the case. We're just showing how this actually has to happen at the molecular level for it to make sense. So the first thing you do here is you need to identify every single chemical that is in this situation, which is just carbon, hydrogen, and oxygen. That is denoted by all the capital letters. That tells you when a new chemical is there. So you look on each side, on the reactant side and the product side. Essentially, this is a law of conservation of mass. What comes in must go out. So I got 1 C over here, 1 C over there. That's balanced. I got 4 H's on this side, and I only have 2 on this side. So that's not balanced. We got to balance those. And then I've got 2 O's right here, and then I've got 3 O's over here. Now, a big mistake a lot of my students make is they look at this and they actually forget that there's 2 chemicals with O's in them. That's two oxygens on one. There's 1 oxygen on another one. So when you're balancing, what you generally want to do is you want to start with the most complex chemicals and work back to the simplest ones. So I'm just going to start with hydrogen because that's the only one that's not taken care of. So I need to get 2 more on this side. So I multiply this entire chemical by 2. This is saying every time this reaction happens, there's 2 molecules of H2O that are produced, which means this goes from a 2 to a 4 because 2 times 2 is 4. And then this O, 2 times 1 is 2. And then we have plus 2, that's 4. Now, a mistake a lot of my students make is they say, well, that's times 2 of this number. It's got to be times 2 of that number, which would be 6, which would be wrong because it's 1 oxygen, then plus 2 oxygens. Then 2 times 1 is going to be 2, and you get 2 plus 2, which is 4. But now we have oxygen, which is our simplest chemical. We do that one last. We put a 2 there. So that tells us every time this reaction occurs, we have 1 methane molecule reacting with 2 oxygen molecules to produce 1 carbon dioxide molecule and 2 water molecules. So what you need to understand here is we are now balanced, okay? So if I'm producing 6 moles of CO2, to make 6 moles of CO2, this reaction has to happen 6 total times. So if this reaction happens 6 total times, what that means is that for my ingredients, every time the reaction happens, I use 1 mole of this, 2 moles of this to produce 6 moles of that, or produce 1 mole of that. So if I produce 6 moles of that, I multiply this entire reaction by 6 because it's going to happen 6 times. And then for oxygen, you do 6 times 2, and that's 12. So 12 moles of oxygen were used in this reaction to produce 6 moles of CO2. Hopefully this helps you, and I hope you have a fantastic day. See ya.